Google has just introduced a new artificial intelligence model called Embedding Gemma, and it's turning heads for one big reason. It's tiny, yet extremely powerful. With just 308 million parameters, it runs directly on a phone or laptop in under 15 milliseconds. Even more surprising, it understands over 100 languages and ranks among the best models under 500 million parameters. So how can something so small perform this well? The power of small. For years, the race in artificial intelligence was all about size. Bigger models with billions of parameters usually meant better results. But bigger also meant slower and harder to run. Only the largest tech companies with huge data centers could handle them. Now, Embedding Gemma is flipping that idea. With its 308 million parameters, it's considered tiny in today's AI world. To give you context, many famous models measure in the billions. Yet Gemma scores at the very top of benchmarks for models under 500 million parameters. That's like a small car outrunning vehicles with engines twice its size. So how does it do it? Part of the answer lies in its smart design. Instead of reading text word by word like a story told one sentence at a time, it looks at the entire sentence at once. This technique, called bidirectional attention, allows it to understand the deeper meaning behind words, not just the order they appear in. Speed that feels instant. Imagine searching through hundreds of files on your computer. Normally, even with strong internet, it might take a few seconds to find what you need. With Embedding Gemma, the wait is almost invisible. On Google's Edge TPU hardware, it can create an embedding, a special numeric summary of text, for a 256-word snippet in under 15 milliseconds. That kind of speed matters. When answers appear instantly, people actually use the tool. If an AI takes too long, most of us just give up. This is where Gemma shines. It makes advanced AI feel as quick as typing a message. Built for the world's languages. Another powerful feature is its multilingual ability. Gemma was trained on over 100 languages. That means it won't break down if you mix English with Spanish, Hindi, or German. For people around the globe, this is huge. Large models often perform well in English, but struggle with other languages. Gemma is designed to bridge that gap, making AI more inclusive and useful no matter where you live or what language you speak. What are embeddings, really? To understand why Embedding Gemma is such a breakthrough, we need to know what an embedding actually is. Think of an embedding like a secret code. Instead of storing every single word exactly as it appears, the model translates it into a long list of numbers. These numbers capture the meaning of the text. For example, the words king and queen may look different on the surface, but in an embedding space, their numbers sit close together because the model understands they're related. Now imagine you have thousands of documents saved on your computer. You want to quickly find the ones that mention climate change in the same way you mean it, not just any random mention of climate or change. That's where embeddings shine. They group words, phrases, and ideas by meaning, not just by exact spelling. This is what makes search smarter. Instead of just matching keywords, the AI compares embeddings. If two passages have vectors that point in a similar direction, the model knows they're talking about the same concept, even if they use different words. Shrinking vectors without losing power. But here's a challenge. Embeddings can get huge. A single piece of text might turn into a 768-dimensional vector. Storing millions of those can eat up memory quickly, especially on smaller devices. Google found a clever way around this. They used a method called matryoshka representation learning. Just like Russian nesting dolls, where a small figure fits neatly inside a larger one, this technique lets the model shrink vectors to different sizes, 512, 256, or even 128 dimensions, without needing to retrain everything from scratch. That means if you're building a search tool for a giant cloud system, you can use the full 768 dimension vectors for maximum accuracy. But if you're running an app on a phone or need to save space, you can scale it down to 256 or 128 and still keep most of the quality. It's like compressing a high-resolution photo into a smaller file, but without making it blurry. This is a huge deal for developers who want to bring AI to the edge. It balances speed, memory use, and accuracy in a way that wasn't possible before. Private and offline by design. Another big selling point is privacy. Most large AI models depend on the cloud. You send your data to a server, and the AI sends back an answer. That works fine if you're okay with your information leaving your device. But what if you're dealing with sensitive emails, private notes, or company files? Embedding Gemma was built to run completely offline. That means your information stays with you. You can search across your documents, emails, or even notifications without sending anything to Google's server. Imagine being on an airplane with no Wi-Fi, but still being able to ask your device questions and get useful results instantly. This local-first design isn't just convenient. It could be the future of how we interact with AI, where speed and privacy come first, and the cloud becomes optional, not required. Training at scale. To build something this efficient, Google had to feed Embedding Gemma a massive diet of text. In fact, the model trained on about 320 billion tokens. That's pieces of words. From websites, technical manuals, code, and even synthetic examples made to cover tricky cases. The team didn't just throw in random data. They carefully filtered out poor quality text and removed harmful material, including strict protections against illegal or unsafe content. That way, the model learns language patterns without picking up unwanted noise. And here's another rule. On the official benchmark leaderboard, any model trained on more than 20% of the test data doesn't count. That prevents companies from cheating by memorizing the answers. Even with this limit, Embedding Gemma still rose to the very top among models under 500 million parameters. Fine-tuning for special jobs. One of the most exciting parts about Embedding Gemma is how easily it can be adapted. Developers can take the base model and fine-tune it for their own projects. For example, researchers at Hugging Face tried this with a medical dataset called Myriad. They gave the model around 100,000 examples and trained it on a single NVIDIA RTX 3090 GPU. The whole process took just 5.5 hours. The results were striking. The accuracy score jumped from 0.834 to 0.886. Now, that might look like a small change, but in fields like medicine, even a tiny boost can make a huge difference. And here's the kicker. The smaller fine-tuned version actually beats some much larger, well-known models. This proves something important. You don't always need the biggest AI. With the right data and a smart design, a small, well-tuned model can outperform a giant. The bigger picture. With this release, Google's AI family is starting to take shape. Each tool now has its own role. Embedding Gemma is the small, privacy-first model that runs offline and focuses on understanding meaning. On the other hand, Gemini embeddings are built for massive power in the cloud, handling the heaviest workloads with maximum accuracy. This split makes things clearer for developers. If you're building an app that needs to stay private and run on a phone, Gemma is your go-to. If you're running a global platform with millions of users, Gemini might be the better choice. And to make it all easier, Google has opened the doors. The model weights are available on Hugging Face and Kaggle, so anyone can download and experiment. Tools like Ollama let you install it with a single command. LM Studio makes testing simple. Llama.cpp compiles it to run on smaller machines, while Apple's MLX ensures it runs smoothly on Macs with Apple Silicon. Even Transformers.js lets you run it directly inside a web browser. It's clear this isn't just a research project locked away in a lab. From day one, Google designed Embedding Gemma to be practical, usable, and open. Outro. As we've seen, Google's Embedding Gemma is more than just another AI model. It's a bold experiment in making intelligence smaller, faster, and more private, without losing quality. It can understand over 100 languages, run offline on a phone, and even be fine-tuned for fields like medicine in just a few hours. For developers, it's already easy to use across platforms like Hugging Face, LM Studio, and Apple devices. But the bigger story is what this represents. For years, AI was all about size and cloud power. Now we might be entering an age where small, efficient models give people more control. So what do you think? Are these compact offline models the real future of AI? Or will massive cloud systems always dominate? Share your thoughts below. And don't forget to subscribe for more deep dive stories into the world of technology.